Wave nature of light. So light is a transverse electromagnetic wave. So this we know already. So the electromagnetic wave or the light, okay, both the same only. It will travel in a transverse medium only, and the wave nature of light was first illustrated through the experiments on interference and diffractions. Okay, the first illustrated experiment, it based on the topic interference and diffraction. So the wave will get interference and also it get diffracted. So like all electromagnetic wave, so light can travel through a vacuum. Okay, so the transverse nature of light is demonstrated in polarization. So polarization is nothing but when the charges are randomly moving, it get polarized when I apply the electric field or magnetic field. Okay, so that is called polarization. Okay, so now we'll get into the topic wave optics. So wave optics deals with the wave characteristics of light with the help of wave optics. So we are going to learn in details the phenomena of interference, diffraction and polarization. So we are going to detailedly study about the topic what is interference, what is diffraction and what is polarization. Even the law of reflection and refraction are proved only with the help of the wave optics. So without wave optics, we couldn't know what is reflection and what is refraction. So now light propagates as a wave. So light will propagate as a wave and it is transverse in nature. So its direction of propagation is still represented as a ray only. Okay. So then you can see the figure in clearly. So when I put some stone into the pond water or some water which is a stagnant water, so what will happen? So suddenly it will create some circular motion like this. Okay, like this we will have some this shape circle motion. So in this case it clearly denotes that, so when I put some stone into the pond water, so the vibration it starts and it comes like this and it ends in this way. Okay, first it starts with the circular motion, then to the last to your eye you can see only this line. Okay, after some distance. Okay, so this circular motion is caused by due to this. Okay, so this circular wave is caused by due to this small circle, and this is caused by due to this, and this is due to this. So like that it will vary. Okay, so an example for wave propagation is the spreading of circular ripples on the surface of still water from a point at which stone is dropped. So the molecules or particles of water are moving only up and down. So up and down it's nothing but it oscillates. Up and down means oscillate. So when a ripple passes out that part, all these particles on the circular ripple are in the same phase of vibration as they are all at the same distance from the center. Okay, so this circle will have the same distance. Okay, so this circle will have the same distance. So when I drop this stone, what will happen? Okay, the circle will continues to form with the same distance. So for example, if I'm seeing from this place, okay, this is your eye. Okay, if I'm seeing from this place, I can see only the in the edge at the last I can see only like this. Okay, I cannot see the circular motion. So it will, so the wave front will be very less. So wave front is nothing but the wave is going in this way. So this is called wave front. If the wave is created by this and this wave is created by this and this wave is created by this one means, so the when the wave is going in front it is called wave front. Okay, clear? Yes. So a wavefront is the locus of a points which are in the same state or phase of vibration. Okay, so when a wave propagates, so again I'll read that. A wavefront is the locus of a points which are in the same state or phase of vibration. So locus of the point in the sense, so it will be like this. So if I have the circle after dropping a stone, I will have the circle like this. So in this, I have number of wavelets. Okay, so this is the locus point. Okay, I will have number of wavelets and this will form what? another wave, and again I will have the wavelets here. Again it will form like this. Again it will form another circle. So like that it will go. So this is called what? The locus point. So when a wave propagates, it is treated as the propagation of wave front. The wave front is always perpendicular to the direction of the propagation of wave. So always it will be perpendicular. Okay. For example, I have the I'll have the propagation of wave in this wave means, so the wave front will be perpendicular. So like this. Here you can see the diagram clearly. So as the direction of ray in the direction of a propagation of wave, the wave front is always perpendicular to the ray. So the shape of a wave front observed at a point depends on the shape of the source and also distance at which the source is located. So at a point source located at a finite distance gives the specific spherical wave fronts. Okay, if the point source is located at a finite distance, which means if the distance is equal, so that wave will create the spherical wavefront, and extended or line source at a finite distance gives the cylindrical wavefronts. If I have the line source at the finite distance, which means if I have a distance in this way means, so in this way means I will have the cylindrical wavefronts. If I have the finite distance like this means I will have the circular, and the plane wavefronts are received from any source. Okay, either it comes from the cylinder point source or the line source. So this is the line source and this is the point source. So point source will be the, yes, what is meant by point source? Point source will be the circular and line source will be the cylindrical, and source is infinity. Whatever may be the source, okay, you can get the plane wavefronts like this. Okay, so this is what you have we have studied about wavefronts. So hope you can understood clearly what is wavefronts and what is wavelets. So let's continue to see the next topic, Huygens principle. So this also based on this only. So we will see it in the next chapter.